Hello, my dear students. In the previous session, we have gone through the different types of problems on numerical aperture and acceptance angle. In this session, we will focus on few of such a types of problems. So, here is question number 8. See, an optical fiber has a numerical aperture of 0.20 and a refractive index of cladding is 1.59. Determine the acceptance angle for the fiber in water, where they have given the refractive index of water medium is 1.33, and this question was asked in university examinations in May 2017 for 4 marks. So see, this question is quite a different one. Here they have mentioned the numerical aperture of 0.20, and then we have the refractive index of cladding as 1.59. So here first of all we'll write down the given quantities. So here this is Na, and the value of Na is what? It is 0.20. And then we have a refractive index of cladding, so it will be mu2, and the value is what? 1.59. What we have to find out is, we have to find out, so here to find the acceptance angle, so it will be theta naught, but this is when the fiber is kept in water. So here I'll write water. Now see, the formula for acceptance angle is what? We know the formula. It is a theta naught is equal to sine inverse of under root mu1 square minus mu2 square whole divided by mu naught. Now if you remember, I said while explaining the mathematical expression that whenever there is a case that optical fiber is kept in some other medium, then in the formula of acceptance angle as well as the formula for numerical aperture, we divide this particular under root term by mu naught. And here this mu naught is nothing but it is the refractive index of that particular medium where the optical fiber is been kept. So here optical fiber is kept in water, so here the value of mu naught, it will be 1.33. so this will be the value for refractive index, that is the mu naught. So now we will find out the value of acceptance angle. Again, if you observe this formula carefully, we know the value of this mu2, that is the refractive index of cladding, but we don't have this value of mu1, that is the refractive index of core medium. So first of all, we have to find out the refractive index of core medium, and then we'll go for this acceptance angle theta naught. Now, how to find out that value of mu1? Here they have mentioned the numerical aperture as 0.20. Now see, this particular value of numerical aperture, they haven't mentioned that where the value of this particular value is been chosen. So here we will assume that this value of numerical aperture of that optical fiber is for air medium. This is for what? Air medium. So first of all, we will use the formula of this Na for air medium, and then see the formula will be what? For Na, again for air medium, it will be under root mu1 square minus mu2 square. So this is the formula for Na of that optical fiber when it is kept in air medium. So here we have, like, we can also divide here by mu naught, but we know the refractive index of air, it will be what? 1. So this will be divided by 1, so we can easily eliminate this particular part. So here first of all we will find out this particular value of mu a or mu1. Now here we know the value of Na for air medium, as well as we know the value of this mu2, that is the refractive index of cladding. So here in solution, first of all we will find the value of this mu1, that is a refractive index of core medium, and then we will substitute this particular value of mu1 into this particular equation here, mu1, and then we'll find out this acceptance angle theta naught. So here first of all we'll find out the value of mu1. So here the equation is Na of air is equal to, it is mu1 square minus mu2 square. Now by arranging the terms here, I can write this mu1 as, it will be under root, this will be what, mu2 square plus Na whole bracket square. I have just rearranged the terms by squaring the equation. So here now I can substitute the values. So the value of mu2, it is what? It is 1.59 bracket square plus the value of Na, it is 0.20 bracket square. So now by doing the calculation, here I can write this is equal to, so after doing calculations, we'll get the value of this mu1, that is a refractive index of core medium, as 1.6025. So this is the value of refractive index of core medium. So now as we have the value of this mu1, so here in this equation we will substitute mu1 over here. We know the value of mu2, that is for cladding, as well as we know this mu naught, that is the medium in which optical fiber is been kept. So here I'll write the next solution as, see, this will be theta naught will be equal to, again I'll write the formula over here, sine inverse of this under root mu1 square minus mu2 square whole divided by mu2 mu naught, sorry. So here this will be sine inverse of, the term is what, it is under root here mu1 square. So value of mu1 is what, 1.6025 bracket square minus mu2 is what, 1.59 bracket square whole divided by mu naught, and the value of mu naught, that is the refractive index of water, it is what, it is 1.33. So here by doing calculations we can write this equation as sine inverse of, so by calculating these values we'll get the value of this particular whole term, it will be 0.15, and then simply by finding the inverse of sine of 0.15 will get the value of this theta naught, that is acceptance angle is 8.6 degree. So this is what, this is the acceptance angle of that particular optical fiber when it is kept in the water, when it is kept in the water. I hope you understood this particular question, because here the important thing is what, they have asked the acceptance angle for this particular fiber when it is in water. So just remember that whenever they have mentioned that the fiber is kept in some other medium, then we have to divide by this particular term mu naught. So just remember this one. Now we'll go for the next one. So here the next one is question number 10. A step index fiber has a numerical aperture of 0.16, a core refractive index of 1.45, and core diameter of 90 mm. Calculate first one the acceptance angle, and the second one is a refractive index of cladding. So here they have given the numerical aperture as 0.16. So here we'll first of all write down the given quantities. So given it is Na will be equal to 0.16, and then they have mentioned the core refractive index, so that is nothing but mu1, so it will be 1.45. Again they also have mentioned the core diameter of 90 mm, but see, we have to find out the acceptance angle and the refractive index of this cladding, and we know that in both of the formulas we don't need core diameter, so here we can neglect it. So here it will be then to find, the first one is acceptance angle, so it will be theta naught equal to question mark, and the another one is a refractive index of cladding, so it will be mu2 Now comes to for the formula. So here, to find the acceptance angle, as they have given the value of NA, so here we will use the formula as sine inverse of NA. So this will be the nothing but it is what? It is the formula for acceptance angle, and it will be sine inverse of NA. So by using this formula, we can easily find out the value of acceptance angle. And then for the second one, that is a refractive index of cladding. See, they have mentioned the value of Na. So again, we will use the formula of Na only. So the formula of Na is what? It is under root mu1 square minus mu2 square. So here we know the value of Na as well as we know the value of mu1. So we can easily find out the value of mu2. Again, see here there will be a term of divide by mu naught. But again, here they haven't mentioned that where the fiber is been kept. So we simply assume that fiber is kept in a air medium. So here the refractive index of air is 1. So there is no need to divide this particular term by any other term. So here now we'll do or we'll perform the calculations. So solution, first one, it is theta naught equal to sine inverse of Na. So now we will substitute the values over here. So sine inverse of Na is what? It is 0.16, and then we'll get the inverse of this particular value as 9.2 degrees. So this is what? This is the value for acceptance angle for given optical fiber, 9.2 degrees. Now we'll calculate the refractive index of cladding. So here the formula is again, this will be the this Na will be equal to under root mu1 square minus mu2 square. Then again, by arranging the terms, here I can write the formula for mu2 as under root mu1 square minus Na square. So by substituting the values over here, this mu1 is 1.45 bracket square minus the value of Na is what? It is 0.16 square, and then by doing calculations will get the value of this mu2, that is a refractive index of cladding, as 1.441. So this is what? This is the refractive index of cladding. Here they have given the Na, that is numerical aperture, as well as along with we have the value of refractive index of core medium, and we have to find out acceptance angle as well as the refractive index of cladding. Then we have these two simple formulas, and then by doing simple calculation will come to the final result. So now we'll go for the next problem. So here is question number 11. It is calculate the numerical aperture of step index fiber having mu1, that is refractive index of core medium, it is 1.48, and mu2 is the refractive index of cladding, it is 1.46. Then what is the maximum entrance angle for this fiber? So here we have to find out Na, that is numerical aperture, and they have given the values of mu1 and mu2. So first of all, here we'll write given. So it is the mu1 and the value is 1.48, and then again we have mu2 as 1.46. Then to find here, first of all, we have to find out the value of Na, that is numerical aperture, and then we have to find out the maximum entrance angle. So here, first of all, we'll write this Na as question mark, and the second one is what? Maximum entrance angle is nothing but the acceptance angle. So it will be theta naught. Again, the formulas will be, first of all, for Na, the formula is what? It is under root mu1 square minus mu2 square, and that of acceptance angle is sine inverse of NA, that is numerical aperture. Because from equation 1 or first formula will have the value of NA, and then we will substitute it in the formula for this acceptance angle. So now by doing calculations here, it will be solution. First of all, it is for NA, that is numerical aperture. Here the formula is mu1 squared minus mu2 squared. Now we will substitute the values over here. So the value of mu1 is 1.48 bracket square minus 1.46 bracket square. So here by doing calculation, we'll have the value of numerical aperture as 0.24. So this is the value of numerical aperture for this particular given optical fiber. Now we have to find out the value of acceptance angle. So here the formula will be just as it is theta naught is equal to sine inverse of NA, that is numerical aperture. So here we will substitute the value as 0.24. Now, so the value is 13.88 degrees. So this is the value of acceptance angle for this particular given optical fiber. So here this was again another one simple problem. Now we'll go for the next one. So now here this is the last problem on numerical aperture and acceptance angle. So a bare optical fiber with no cladding is kept in air medium and has fractional index difference 1.2%. Calculate the acceptance angle of fiber. The question is what? Here it is a bare optical fiber with no cladding, and that optical fiber is been kept in air medium. Again, they have mentioned that the fractional index difference is 1.2%, and we have to find out the acceptance angle. This question was asked in May 2019 for 3 marks. Now see, the question is simple one, but little bit different one, because here they have mentioned the optical fiber with no cladding. That means what? It is simply a core medium which is kept in a air. So ultimately, what happens, or what we can conclude from this, as this is the bare optical fiber, that is, there is no cladding, and that optical fiber is kept in a air medium. So ultimately, here the cladding will take the refractive index of air medium. So here we can say the refractive index of cladding is what? It is that of air medium. So here, first of all, I'll write this mu2, that is refractive index of cladding, it is as 1, because the refractive index for air, it is 1. So here I'll mention air. Again, they have given the fractional index difference, so it is nothing but delta. So delta is what? It is 1.2%. So here I can write this one as 1.2. Again, percent is, that means divided by 100. So this becomes 0.012. So this is the value of this delta. Now what we have to find out is what? Here we have to find the acceptance angle, that is theta naught. Now again the formula for acceptance angle, it is what? Here I'll write formula. See, the acceptance angle is nothing but sine inverse of under root this mu1 square minus mu2 square. Mu1 square minus mu2 square. Now see, to find this acceptance angle theta naught, we must have the values of refractive indices for both core and cladding. But here we only have the refractive index for cladding. But so here, first of all, we have to find out the refractive index of core medium, that is mu1, and then we'll be able to find this particular acceptance angle. So here, to find this mu1, we will use this fractional value, this one delta. So here the formula for delta, it is what? It is mu1 minus mu2 divided by mu1. So this is the formula for fractional index difference. And here we know the value of delta as well as we know the value of this mu2. So we can easily find out this mu1. So here I'll rearrange this equation. So here this equation will be delta into mu1 is equal to mu1 minus mu2. And then we can write this equation as, so here I'll arrange this equation as mu1 is equal to mu2 divided by 1 minus delta, mu2 upon 1 minus delta. So first of all, here we will use this particular formula mu1 equal to mu2 upon 1 minus delta, as we know the value of mu2 as well as the delta, so we can easily find out this mu1, and then we will substitute this mu1 into the this formula of acceptance angle here. So we'll have the value of acceptance angle. So here we'll first initially we'll find out this mu1. So it will be mu1 is equal to mu2 upon 1 minus delta. So this will be the value of mu2 is 1 divided by 1 minus delta is what? It is 0.012. So here the value of this mu1 is 1.0121. So this is the refractive index of core medium. And now from this, or we will substitute this value into the formula for acceptance angle, and then we'll have the value of acceptance angle. So here this will be theta naught is equal to sine inverse of under root this mu1 square minus mu2 square. So this will be sine inverse of under root this value of mu1 is what? It is 1.0121 bracket square minus mu2. Mu2 is what? It is 1. So this will be 1 square. Then by doing calculations, so here the value of acceptance angle, it is 8.96 degree. So this is what? This is the value of acceptance angle for given bare optical fiber, that is without cladding. So this formula, the main thing is what? Here they have mentioned that the optical fiber is with no cladding. That was the important part. So whenever the question is like this will arrive in the examination, you simply assume the refractive index of cladding as air. Sometimes they will mention like a bare optical fiber is kept in a water. So if they have mentioned like this that the optical fiber is been kept in water and that is with no cladding, then definitely we'll take the refractive index of cladding as a refractive index of water. So just mind the difference between these two. Okay. Now I hope you understood all the problems that we have taken in the previous 2 3 sessions. So these are the variety of problems and they may ask in your university examination. Now we'll just focus on the difference between the SI, that is step index fiber, and the graded index fiber, but just in a tabular form, because sometimes such a type of questions are asked in the university examination. So here this is the difference between step index fiber and graded index fiber in a tabular form. So in May 2014 and May 2017, this question was asked for 4 marks, and that was the question was quite simple. The differentiate between SI and GRIN fibers. So here we'll simply go through these two the difference between these SI and graded index fiber. So we all know that in step index fiber, the discontinuity of index profile at core cladding junction. So as we know that the refractive index of core medium for step index fiber is constant, and that is different from the refractive index of cladding. So at core cladding junction, this core cladding junction, the value of refractive index suddenly changes from mu1 to mu2. So that is, we say that there is a discontinuity of index profile. But in case of graded index fiber, the refractive index of core, it decreases gradually to attain the refractive index of cladding at core cladding junction. So this is the major difference between SI and graded index fiber. The second one, we can say the refractive index of core is constant, but in case of graded index fiber, the refractive index of core medium decreases nearly in a parabolic manner. Third one, we say, or in step index fiber, the attenuation value is a little bit higher one as compared to graded index fiber. So here in SI it is high attenuation and here it is low attenuation. Again, I would like to remind you all, the attenuation is nothing but a data loss while propagating the data transfer by using light. So here attenuation, and as I said, the attenuation is measured in dB per kilometer, that is a decibel per kilometer. And then we have the last point, that is in step index fiber, for a given diameter of core, the numerical aperture is greater. But for graded index fiber, for given diameter of core medium, the numerical aperture is less, or it is compared to SI, the value is a little bit lower one. So this is the difference between step index fiber and graded index fiber. So I hope, my dear students, in today's session, what we have discussed, we have gone through some problems, different types of problems, which were based on the numerical aperture as well as acceptance angle. And then in the last session, at the last, we have discussed the difference between step index fiber and graded index fiber in tabular form. And remember, this question was important as this was asked two times before for 4 marks. So in next session, we will go for an important concept in optical fiber, that is V number. V number, or sometimes we called it as a normalized frequency or cut off. And this is basically the parameter which tells us about the number of modes propagated or supported by a particular fiber. So we stop here, and then in next session we'll go for V number or normalized frequency. Thank you so much.